Okay, this next person brings me great joy, and I'm so happy that I'm getting to introduce them. Douglas is a statistician, a developer at Absalon, and a friend. His journey with Shiny began with his aim to share his insights and findings, especially from complex models, into a reader-friendly way. With many honorable mentions from POSIT contests as well as several scientific papers written by him, he's a man of many talents. In my experience, he is also one of the best people to talk to any given day, where he would happily talk to you about sports, the world, and everything in between. Today, Douglas will dive into how to measure the performance improvements in a Shiny app using the Shiny benchmark package and share with us this powerful tool. Take it away, Douglas. It's all yours.
Okay. Yeah, thank you very much for this kind introduction, Dipansha. And yeah, so I also need to say thank you very much for everyone that is attending this tutorial today. And I will be talking about a package in which I had the opportunity to be one of the developers. The name of this package is Shine Benchmark. I think that the name tells by itself, even though I will present you the idea behind the package and some of the functionalities as well. Here is the content of the presentation. So I will give you some motivation about how to use Shine Benchmark and why we created that. And most of the presentation will be in R, and I will present you some of the features and I will run some code with you. And at the very end, I will wrap up with some takeaways, and also I'll be open for your questions. Good. Let's start talking about Shine Benchmark. I will need to repeat a lot of things that you heard during this day in Shine conference. That is the fact that Shiny is such a great tool, and it allows us to create a prototype really quick. So you can have an idea during the morning, and at the end of the day, depending on your experience, you can even have a deployed application. But even if you are a beginner, you are able to, in a few hours, create something to show to your users, and this is awesome. However, it also can bring a kind of problem for you, because when you show your prototype, people, they will love that, and they will start requiring new features for you. And the list of new features will never end. And then sometimes you have some deadlines and you need to deliver the features, and you don't want to do not deliver something for your users, right? So you are going to deliver the features as fast as you can. However, sometimes, and it really often happens in practice, the code base healthy is not the best one. The structure of the application is not the best one. And sooner or later, it's going to be a problem for you. So it's for a good reason, of course, because you want to satisfy your client. You want to provide them a lot of features, but at the same time, the list of technical debts can increase as faster as the number of new features that you provide for your users. Yeah, so as I said, sooner or later, performance will be a topic in your dailies and in your meetings, because the user will say something like, yeah, I really love this application. However, when I click on this button, it takes 30 seconds to display this chart, and it's too long. I don't want to wait for such a long time. And then you know what happened, because in the past you had a lot of technical debts. You didn't have had time to fix the technical debts, and now the users, they can feel that the application is not as faster as it should be. So you know it could happen, but now you have the opportunity to improve the application. So you can think about different ways to improve the application, of course. So sometimes it's just piece of code that was not well implemented, and then you can use a package, a smart package that will already fix things for you. Some other times it's just a data manipulation that is not good, so you can move it to a database view, for example, or maybe you can even improve the R code and make it faster. And sometimes it's just some logic issues because you didn't have enough time to think about the feature when you were developing. So yeah, the list of technical debts, it can be huge, and you know how to find the bottlenecks of the application, because yeah, we have a lot of tools in R and in Shiny to identify bottlenecks. The question is, okay, I have a list of technical debts, but how to present the performance improvement for my clients, my users? I can just tell them like, okay, the application is faster, but it's not as analytical as it should be. We know how to compare the numbers and how to give such great statistics for the users. So you can do more and you can give some more insights like now the application is 2 times faster than before, for example. It's much more informative for the users, and also it makes it shows your work better to your users because now you are not delivering features, but you are showing how faster is the application now that you are working on that. And well, we have a lot of tools in R to check performance. And here, when I'm talking about performance, I'm focusing on the time. I'm not thinking about memory usage and other things. It's just on time. And we have a lot of packages and functions in which you can use to check the performance in our R code, right? And the steps are more or less find the bottlenecks, then you check how long does it takes to run the code in the current version, improve the code, and check again how fast is now the code. Then you have these two numbers you can compare. So it's super easy, but you need to follow these steps. But when we were talking about Shiny, there's a new thing here. It's not only R, there is the connection with the browser and the interactivity. The user is playing around with the application. So actually what matters for us is how long does it take to display something for our end user, right? For our client. And it can be a little bit more tricky. However, we still have some nice tools to do the job. So for example, you can think about Cypress or Shine Test 2, which is the one that I will focus in this presentation here. So this package, they can simulate a user in your interface, and then you can record what you call end-to-end tests. So you can record some interactivity with this application. And if you can record this interactivity, you can also record how long did it take. So you can collect the times, right? The problem is sometimes it's a really manual job because you need to identify, for example, in R, you need to identify the bottleneck. You need to go exactly in that part of the code, and then you need to check. You need to, if you have several different versions of your application, you need to go in that very same place for each one of the versions, collect the time, and then compare it later. And it's kind of manual, right? But however, we can think about how to use those libraries to create something more automatic and that allow us to compare different versions of the application. So basically, that's what Shiny Benchmark is about, how to combine those things in a nice syntax so it will be really easy for you to compare the different versions of your application. And then when you think about the different versions of your application, it can be a huge number of versions because you can have different developers working in different parts of the application. And for each one of the improvements that the developers are doing, you can go in the application and check how faster is that right now. So it can have like more than 10 or 20 different versions. And so it's kind of hard to do it manually. So the idea of the Shiny benchmark is to make it easier for you. And I hope that at the end of the presentation, you agree that the syntax is quite easy to use. What do you need to use Shiny benchmark? Just two things. The first thing is you have different versions of your application and you are using Git. And the different versions of your application, they are in different Git hash or tags or branch names, different branch, sorry, or something that you can use Git checkout. Everything that you can use Git checkout, you can use to compare the performance. The other ingredient is some kind of end-to-end tests, and right now we accept Shine Test 2 and also Cypress. So if you have a set of tests using one of those, you are good to go. The assumption here is basically that the R version does not change in these different versions of the application. you have access, or maybe you already have access to this presentation, then you can have a look at the links. Shiny Benchmark is on CRUN, so it's super easy to install. However, if you want, you can install the developed version from the GitHub. Also, there is a blog post about it and also a tutorial. Okay. Another thing that I have in this presentation that may be useful for you is the code that I'm going to use right now. So you can go to my GitHub account and take it and have a look and try to understand it. And now I'm going to the most difficult part, that is the demonstration, and it will be a live coding. And as everyone knows, it can be problematic sometimes. But let's hope it will not be the day that it will be problematic. Good. So most of the things here are already prepared. I'm not going to code with you the application and the tests because I want to focus on the Shine benchmark, of course. But I need to show you the application. So I will start showing this simple and ugly application. And that's the last time that you're going to look at this, I swear. And it has 3 buttons. So when you click in the first button, it's going to take around 4 seconds to display the output. When you click on the second button, it's going to take around 2 seconds, and in the third button, around 1 second. And I'm saying around because I put some random noise just to make it more fun. Good, so this is the application, super simple, and it was on purpose because it will be really easy to improve the performance of this application. Because basically the time that you can see that it takes to render the output, I'm just asking for the computer to sleep for a while, okay? And I have this vector that controls the time that each button is going to sleep. So the first one will take 4 seconds, the second one 2 seconds, and the third one 1 second. Okay. Also, we have a set of tests here using Shine Test 2. I'm not going to give you details about it, but the tests are doing exactly the same thing that I did just now. It's just going there, clicking the button, wait for the output. Go to the second button, wait for the output, and so on and so forth. So super simple. And yeah, you can find tutorials about how to create nice tests using Shine Test 2. And I have a second file that the name is a little bit different. So the first one is called set1, the second one is called set2. It's exactly the same thing, but the name of the tests are a little bit different. And it will make sense later when I start showing you the features of this package. Good. We have almost everything because we have our application, and also we have the end-to-end tests here, which I want to collect the performance. I still need the different versions of the application, and then I will create it right now. I will copy and paste some of the code, but basically I will start a Git repo here. Then I will create a branch called develop. Then I will add everything that I have in this repo to this branch. And then I will just commit, put a commit message here. So we have our first version of the application. It's great. Now we are going to work on the performance. So let's suppose that now we are going to move some data manipulation from R to the database, for example. Okay, so we are going to improve this application. And to do so, we are going to create a different branch, which I call feature one. And let's suppose that this change that I did in the application was really good, and now the button takes, the output takes 2 seconds to display, the second one takes 1 second, the third one half a second. So yeah, great. It was super easy to improve this application. Unfortunately, in the real life, it's not like this, but yeah. So in this one, as it is a tutorial and an example, I can use this way. And now I will add this file that I just created. I will commit the message, and now we have the second version of our application. And I will still create a third version of the application called feature 2. And here I will do the same. So I will decrease the time here. So now it's 1, 0, 5, and 0, 25. But also, I want to show you another feature. I'll talk a little bit about it later. So for now, just accept that I'm going to downgrade Shiny. And I will snapshot that. So I'm using renv here. That's a way to manage the package that you have in a project. I'll talk a little bit about it later. So here we have two chains, either the time, and we downgraded the Shiny version. I will add both files here. I will commit a message, and I will check out to the develop branch. So now we have 3 versions of the application, okay? I'm just going to restore here. This is not important right now. Good, so now we have everything. As I said, we just need a set of tests, which we have. We need different versions of the Shine application. We have 3 different versions, and now we can start talking about Shiny performance. As I said, the code that I'm going to run here is in my GitHub, so you can have a look at this, and I will start talking about some of the features of this package. So it's super easy to install the Shine benchmark. As I said, it's on CRUN, or if you want, you can install from the develop version in GitHub. And all you need to run to use Shine benchmark is a named list with the commits. And again, it can be the hash, the commit hash, it can be a tag, it can be a branch name, whatever. In this case, I'm using the branch names that I just created. And also you need the path to the folder in which you have the tests. Here I have something for Cypress, but I'm not going to show you. But if you want to try, there is the test here in the folder, so you can try with Cypress as well. And it's the very same thing. And then I have the folder in which I have the test, the Shine Test 2 tests. And the basic usage, to be honest, is everything that you need to inform to our benchmark function is the list of commits and where are the tests. That's all. You don't need to put anything else. However, because we have some time here and I need to finish in 15 minutes, so I will make it a little bit faster with some other parameters that I will explain in a while. So do not focus on that. Right now, we just need the commit list and also the directory in which we have the tests. When you run the code, it's going to inform you that we created something in a temporary folder because we do not want to mess with the folder that you have here. So we do everything in a temporary folder. We create a lot of files and we play with that. And at the end, we just delete all the trash that we created. So it's going to run the tests for each one of the branches, as you see here, develop, feature 1 and feature 2. And then it will come back to the origin, which is the develop branch. So it's good. So we already run the tests here. And what we have as a result is you can access the object and you have the call. So how did you call the benchmark function? Also, you have the overall time. So it took 25 seconds to run everything. And you have the performance here. So maybe it will be better if I show just one. So if you go to the develop branch, it has a data frame in which it shows in which date did you run this, the replication ID, it will make sense later, the name of the test, so it's out1, out2, and out3, the name of the outputs, and you have the duration in milliseconds here of each one of the tests. Okay, so it's similar. We were expecting like 4 seconds, 2 seconds, and 1 second, and it's more or less what we saw. So really good. You can see that we have the very same structure for the others as well. Oh, it's not called feature 2. It's using renv. And then you have everything that you need here. Now I will start running, and then I will tell you what's going on here. Right now, I'm assuming that people are using renv in the projects, because it's really common that when you are improving the performance of your application, probably you need to install different packages. Maybe you need to downgrade a package. Maybe you need to update a package. So you need to manage the package somehow. And the natural way to do this in R is using renv. So we are assuming that you are using this, and the way to inform it to Shine benchmark is using this flag using renv equals to true. And also you can have some communication with renv if you turn it up, if you turn renv prompt on as well. So as you can see, it was running the tests in develop branch, then it went to feature 1, but then in the feature 2, if you remember, we downgraded Shiny. So it's asking me, do you want to downgrade Shiny? And I say yes. It's going to downgrade Shiny. And later it's going to ask me again, because now in the develop branch it's a different version. And the output is exactly the same. So basically the difference here is that you can handle renv. When I say exactly the same, it's the structure, of course, the times are different, right? Now, I want to talk about a different feature that is also interesting, because when you are improving your application, maybe you are going to create a new button or a new logic in your application, and maybe the tests are going to change a little bit. So you need to do one more step on, or something change in the set of tests. And it's okay, it's all right, you can do that, it's not a problem for us. You just need to inform us what are the pattern of the files that you need to look at in your GitHub, in your Git structure. So it can be just one file, or it can be multiple files, because in terms of organization, maybe you want to break the tests in different files, right? In this case here, we have two different files, and I can inform Shine benchmark which one to use by using this test pattern. So basically what I'm doing here is informing that for the first commit in the list, I want just to run the file that matches set1, which is this file here. For the second commit, I want the set2. And for the third commit, the third branch in this case, I want either test1 and test2, because it also accepts a regular expression. And here in this regular expression, I'm saying that I want everything that matches set and then a number between 0 and 9. So the way it runs is exactly the same. However, the output now is a little bit different. So as I said, for the third branch here, I said that I want to run both files. So when you print the output here, you can see that we have more elements right now. So we have the test for the set1, and also we have the test for the set2. So both files that I showed you. So the names are different here. So you can identify it here as well. And for the others, for example, the first one, we can see that, we can see that we requested only set1, and you have only set1 here. And for the second branch, we requested only set2, and we have only set2 here. So it's good. And now, maybe the most important feature here is to allow some repetitions in the process, because so far I run the code only once. So I go there, run the code only once, collect the time, and that's all. But maybe I'm using a server and there are concurrent users in the server, so maybe the performance of my application can be affected by that. Or maybe we are collecting some data from the database and it's too busy there, and then it's affecting my performance as well. Or something else that is happening in your computer if you are doing it locally. So it's good to have some repetition, because then you don't have just one number that you need to believe, but you can have a look at the distribution of these times, okay? And then in this code here, basically what you need to do is to inform the number of repetitions. So there is this parameter and rep, and in this case, I requested 5 repetitions. And also, as you can see, I just requested one of the set of tests just to make it faster. All right, another thing that's interesting here is that you can see in which iteration we are. So you have some visual information about what's going on. And just a comment that I want to add here is that, as I said, we are creating something in a temporary folder. So we need to create some files and we need to update some of the files in your project. So we use everything in this temporary folder, and at the end we remove everything. So you can be you don't need to be worried by adding some random files to your repo. It's not going to happen here. So at the end of the process, the output will be a little bit different. So now, when you see, for example, the develop branch, it's not only one entry anymore, but now you have 5. So you have this repetition ID. I told you that it would be interesting at the end, so you can control which round was that. So maybe you can even identify, like, okay, when I was running the third round, something happened in the server because it's like an outlier or something, and then you can I don't know, you can see if it's normal, or you can maybe remove this observation if it makes sense. Good. And then you have the entire data to do whatever you want here. So you are free to use the data. However, maybe it can be useful to use some of the methods that we implemented, actually 2 of them. So the summary will give you, for each one of the commits in the list, for each one of the tasks that you had, how many replications we did, what the average in seconds, the median in seconds, standard deviation, minimum and maximum. So you have some summary statistics here for each one of the tests. Okay, it's good, but another thing that I like is the plot. It's a really basic one, but it can be useful when you just want to have a quickly idea of what's going on in your project. So you can have this chart here, in which in the x-axis you have the branches, in the y-axis you have the time in seconds, and the panels are the different tests that you have. And then the content of the chart is the point is the average time, and you have also the minimum and the maximum times. Another nice and interesting thing here is that the branches are organized by the date of the last commit. So I know that the first one that I committed was the develop one, then feature one, and then using our env. So you can see the timeline here as well. And as you can see visually here, it's super easy to identify that the development was really slow compared with the others. And then we can also see that we had an improvement in the performance. So it's super nice to show to your user not only that you are that you solved the problem, or you are working to solve the problem of performance, but you can also measure that and show it visually what's going on in the application. All right, so I see that I still have some minutes, so I'll try to wrap up really fast. So basically, the idea of the package is to make something really simple to use. Basically, what you need is are different versions of your application and some end-to-end tests. If you have that, you are good to go and use Shine benchmark. So the syntax is also really simple.
Sorry for interrupting you. We're kind of out of time.
Okay,
I just
sorry.
want to let you know to speed up. Yeah. All right. Thank you.
Yeah, and please, if you have questions, open source Epsilon, and I will be glad to answer.
All right. Thank you so much, Douglas, for this presentation. We have one question. Just, is the benchmark made over the commits or the branches or both?
It's independent. You can use branches or commit hashes. It can be in the same branch. You just need to provide the hash code. Everything that I can use to run git checkout something, this something is you can use it.
All right. Thank you so much, Douglas, for this amazing presentation. And I definitely have used the package before, and I'm sure people will find a lot of value in using this again.
Yeah, thank you very much, and yeah, enjoy the conference.